Hello. If you found yourself here, it's hopefully because you've decided to, or are considering, studying chemistry for A-level. If so, congratulations. It's a brilliant course which leads to lots of exciting degree and career opportunities. The aim of this series of videos is to give you a grounding in the essentials that you'll need to take your studies further. You'll have met most of the concepts at GCSE, and this will give you a refresher in preparation for your A-levels. In today's video, we're going to have a look at atomic structure. During your GCSE studies, you will have come across subatomic particles and how they're put together to make atoms. You'll also have seen energy levels and the electrons and how they are arranged on those energy levels. And then you'll also have come across how electrons affect an element's place in the periodic table. We're going to have a quick review of all of these today, and I'll show you some ways that these link forwards into your A-level studies. Let's begin by looking at the atom. This model of the atom should be familiar to all of us. It's called the Bohr Model, named after the scientist that proposed it. Now, the Bohr Model built on years of scientific discovery, reaching right the way back to the ancient Greeks, with Democritus who first proposed the ideas of atoms. We now know that we have a quantum mechanical model of the atom, but we don't need to worry about that just yet. What are the important features of this model of the atom? We should hopefully be able to see that this atom consists of a nucleus, wherein we can find the protons and neutrons, and then electrons orbiting around the nucleus on energy shells. Like all modern versions of the atom, this model has the atom being mostly consisting of empty space. Now, what's important to note is that it's the protons in the nucleus which determine which element this atom belongs to, and that in atoms of an element which are neutrally charged, the number of electrons is equal to the number of protons. This particular element is lithium, so this is an atom of lithium. You can see it has 3 protons, 4 neutrons, and 3 electrons. So the positively charged protons cancel out the negatively charged electrons to give the atom an overall neutral charge. The mass of this atom would be 7, as there are 3 protons and 4 neutrons, and protons and neutrons are the subatomic particles that we consider to have mass in most of our calculations. As a chemist, most of our information on elements comes from the periodic table, and if you can read the periodic table, that saves you a lot of time and effort trying to memorize things. All atomic symbols on the periodic table follow the same basic appearance. They have an atomic symbol, which is the shorthand chemists use to refer to an element. They have a mass number. They also have the atomic number. Now, the atomic number is like a fingerprint for the element. Every element has a set number of protons and therefore a set atomic number. So, for example, all atoms of helium will have 2 protons. All atoms of hydrogen consist of 1 proton, and this is given by the atomic number. The mass number tells you the relative atomic mass of an element. Now, we're used to seeing whole numbers from GCSE, and so if we take this helium for an example, we can see that the helium has a mass number of 4, and we can then work out that that means it has 2 protons and 2 neutrons, because the number of neutrons is the mass number minus the atomic number. Now, as you move forwards into A-level, you're going to start seeing a lot more decimals on your periodic tables, and that's because a lot more elements have isotopes than you've previously realised. We're quite familiar with the idea of copper and chlorine having isotopes, but nearly every element on the periodic table has 2 or more isotopes, and therefore that's how we work out the relative atomic mass. Don't worry about that just yet though. Using the information given on this atomic symbol, can you draw an atom of helium using the Bohr model? Have a go, pause the video, and then check your answer in a minute. So, how did you do? Let's find out. If we use the colour black for the neutrons and red for protons as we did previously, we should hopefully be able to see that this helium atom will have 2 neutrons in its nucleus. It will also have 2 protons, which we'll draw in red. And this here forms the nucleus of the helium atom. Now, orbiting around this there will be electrons. As this helium atom is neutrally charged, there should be 2 electrons. So if we draw our energy level, I'm going to represent the electrons with crosses like this. Now, it's important to remember that electrons always fill energy levels closest to the nucleus first before filling any additional energy levels. That the order they fill in is 2, 8, 8. After that, it becomes a bit more complicated, but we'll have a look at that in a future video. As we were just talking about subatomic particles, it's now time to have a look at electron arrangements, or electron configuration as it's also known. Remember, electrons are arranged on energy levels, or shells, moving out from the atomic nucleus. Now, each shell has what's called a quantum number. This is called the principal quantum number, or n. So n is the principal quantum number. This is a little bit beyond what you'll have seen at GCSE. So the principal quantum number. So if I draw a quick diagram here showing the shells, so the first shell is n equals 1. The second shell is n equals 2. And so on and so forth. And we can use this to refer to the position of electrons around an element. Let's have a go at drawing the electron configurations of these elements. Now, I'm going to give you a little bit of extra information that you may not have been told at GCSE. We should be familiar that electrons fill from the lowest energy level upwards. So in beryllium, for example, we would have 2 electrons on the n equals 1, or the first energy level. Now, what you need to know is that electrons fill energy levels singly until the energy level is more than half full. At that point, they begin pairing up. So you can see here that beryllium has 4 electrons because it has an atomic number of 4. So that means that we're going to have 2 electrons in this first energy level, and then a further 2 in n equals 2, or its valence shell. Now we can see the electron configuration of beryllium. Now we can write this in a shorthand like so: 2, 2. If we look at magnesium, I should be able to demonstrate this idea of the pairing of electrons a bit more fully. So yet again, we can see that magnesium has an atomic number here of 12. So if we place our first 2 electrons into the lowest energy level, or n equals 1, we should then see that we have 10 more electrons to place on the energy levels. So we begin filling n equals 2 singly. So 1, 2, 3, 4. Now, we've still got more electrons to add. We should hopefully be able to see that we can put another 4 electrons into this shell. But now the electrons are going to start pairing up, and I'll represent this with a different colour, just so you can see how that works. So we put 1 there, 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 and there. The magnesium now has 10 electrons in its shells in total, but it should have 12, which means that we're going to need to add 2 further electrons to the outermost or valence shell. It should look like this. So remember, electrons only start pairing up on energy levels when the energy level is more than half full. Have a go at drawing the energy level diagram for calcium, and then writing the electron configuration, and then check back in a moment where I'll go through it with you. Okay, so looking at calcium, let's see how you did. First things first, we should see that calcium has an atomic number of 20, so we're going to have to place 20 electrons in its energy levels. So let's start at the innermost energy level, or n equals 1. We then have 2 electrons there, 18 to go. So we're going to put them in this first shell, or this second shell, sorry, n equals 2. So that goes round, and I'll just change colour again so you can see them pairing up. You wouldn't have to do this on a normal diagram, I'm just doing it so you can see where they've paired. So we've now placed 10 electrons in total, so there's 10 more to go. So we're going to move on to the next shell. Now this shell can also hold up to 8 electrons. So we put our electrons in there, and then we can put 4 more in, so that now is going to pair up like so. And we still have 2 electrons left. We've got 18 there in that diagram in total. We need 20, so we're going to put 2 electrons in the valence shell and There we go. So we now have 20 electrons arranged in the energy levels of calcium. And if we write out the electron configuration, we should hopefully see that it's 2, 8, 8, 2. How did you do? Let me know in the comments. So we've just practiced drawing electron configuration diagrams using the group 2 metals. Why don't you have a go with the group 7 halogens, fluorine and chlorine. First, identify the atomic number so that you can work out how many electrons you need to be drawing in, and then try and draw the diagrams. Pause the video and check back in a moment. Okay, so for fluorine then, we should hopefully see it's got an atomic number of 9. So we're going to place 9 electrons in the shells. So remember pairing up when the shell is more than half full. So we've already got a total of 6 in there, 7, 8, 9. You can see that fluorine therefore has 7 valent shell electrons, and the electron configuration 2, 7. If we look at chlorine from the same group, we're going to put 2 electrons in this first shell. And we're going to do 1, 2, 3, 4, 5, 6, 7, 8 in n equals 2. So we place a total of 10. We're aiming for 17. So we're going to place 7 valence electrons in the valence shell. See there, 7 electrons, giving chlorine the electron configuration 2, 8, 7. How did you do? Now, we should be familiar with Dmitry Mendeleev's periodic table and the fact that Mendeleev arranged elements not only in order of increasing atomic mass, but also based on their properties. We should also know that elements in the same group, which are the columns on the periodic table, have similar properties and react in similar ways. This is because elements in the same group have the same number of valence or outer shell electrons. So for example, all elements in group 1 have 1 valence shell electron. In group 2, they have 2 valence shell electrons, and so on and so forth. Now this section in the middle is the D block, which has some interesting traits with ions, and we'll come and look at that later. If we come over here to what we call the P block, group 3, all of the elements have 3 valence shell electrons, and so on and so forth. It's important to remember this link between the group number of an element and its number of valence shell electrons. Now, your version of the periodic table is going to change slightly moving into A level, but don't worry about that just yet. This basic fact remains the same. I hope you found this useful. It's just been a quick refresher of atomic structure and some of the key points. If you have any questions, feel free to leave them in the comments. And if you're interested in the next steps, you could start reading about atomic orbital theory. You could go and refresh your memory on calculating relative atomic mass and look at how you could do that from isotopic mass. You could also have a look at energy level diagrams and how to draw those to represent the arrangement of electrons around an atom. I've been Mr. Harding. Thank you for joining me on Harding's Chemistry, and come back soon for the next video in our refresher GCSE chemistry course to prepare you for your A-level studies. Have a good day everyone.